on number 5, we have 2 cards being drawn. They're not being put back from a well-shuffled deck of 52 playing cards. I want the probability that the cards are both red. So I want the probability of drawing a red, and then another event's happening, and I want it to be red, but it's given the first card was already red. So there's a lot of reds flying around. It's a little confusing. But at the beginning, we have 52 cards. Half of them are reds, because we have 13 diamonds, 13 hearts. But now, given the condition that a red was taken out, we can't use 52 anymore. There are only 51 cards remaining. Of those 51 cards, and it's no longer half that are red, because we're assuming that we took a red card out already. If I already took out a red card, not only am I down to 51, but I'm down to 25 here. Since we are just multiplying, because it's our multiplication rule, then I can just take 26 out of 52 times 25 out of 51. You could write the fraction 25 out of 102, or you could tell me that it's approximately equal to 0.245. If I want the probability that both cards are kings, we're still considering the first event is a king, the second event is a king given a king already was removed. So you still start out with 52. Half of your cards are not kings. There are only 4 of them. The king of diamonds, king of hearts, king of clubs, king of spades. But if you take a king out, because that's the given condition here, you're down to 51 cards. And a king was removed, so you're down to 3 kings remaining. So if I multiply that out, I'm getting 1 out of 221, which is approximately 0.005. Really unlikely to get 2 kings in a row. Then I want the probability that the cards are a pair. So when I mean a pair, I mean that they're matching. This is kind of a hard way for me to write this up. So I want the probability that you drew a card, and then I want the probability that it matches. So the probability that, this is a very poor way to write this out, but it's given you already took out a card. So of the 52 things that could happen, 52 of them are a card. So it's not really changing anything. But we do need to consider, as always, we've taken a card out. I want to know how many of the 51 cards remaining match the card that I took out. So, and by a pair, I'm meaning that it's, if I take out a jack, the next card is also a jack. That's what I mean by a match. The thing is, we got to consider we have 4 types of jacks. Jack of hearts, jack of diamonds, jack of clubs, and the jack of spades. Now, I'm calling it a jack, but that's arbitrary. That could have been queen, that could have been 2 of hearts, 2 of diamonds, 2 of clubs, 2 of spades. That label is irrelevant. But if I've already pulled one of these out, there are 3 left that match it. And again, that's true no matter what that first card was. If these were all 2s, I pull out 1, there are 3 left that match. Which means the probability of getting a pair when dealt 2 cards is actually 3 out of 51. 0.059. I don't doubt there are other ways to do that. Personally, my first thought when doing it was try to figure out the probability of a pair of 2s or a pair of 3s or a pair, and it gets very, very complicated. This is the easiest way. Hopefully you didn't spend too much time figuring that out on your own.